Hello students, welcome to Sri Vardhaman Vidyalaya online education. Today we will see the part 3 of a chapter 3 metals and non-metals. In this part first we will see the difference between the metals and non-metals. So the difference between metals and non-metals. Metals are luscious that that is they have a property to shine, whereas the non-metals they are not luscious, that is they do not have shining surface except graphite and iodine. All the metal exist as solid except mercury, which is liquid at a room temperature. Non-metals are generally soft and except diamond. They can be drawn into wires. This is known as an ductility. They are non-ductile. The metal can be converted into an sheet. This is known as an mandibility except mercury. They are non-mandible. They are the good conductor of electricity and heat, except lead and mercury. They are poor conductor of electricity and heat, exception. Graphite is a good conductor of electricity. They have high density and high melting point, except sodium, potassium have low melting point. They have low density compared to the metal and low melting point except diamond, which has a high melting point. So these are the difference between the metals and non-metals. Then the chemical properties of a metal. So first we will see the reaction with an oxygen. Most of the metal forms respectively metal oxide when reacting with oxygen. So metal plus oxygen gives metal oxide. So in this one, first example, the reaction of potassium with oxygen. The potassium metals forms potassium oxide when reacts with oxygen. So formula for the potassium is K and oxygen is O2, so it will give K2O. So that is a potassium oxide. Next, the reaction of sodium with oxygen. The sodium metal forms a sodium oxide when reacts with oxygen. So the formula for the sodium is Na and oxygen is O2. When these two reacts, it will give Na2O, that is sodium oxide. Lithium, potassium, sodium, etc. are known as alkaline metal. So alkaline metal reacts vigorously with an oxygen. So the potassium, sodium and lithium, they will react vigorously with an oxygen. Next, the reaction of a copper metal with oxygen. The copper does not react with oxygen at room temperature, but burnt in air it gives oxide. So Cu plus O2 gives CuO, that is copper oxide. Silver, gold, platinum do not combine with an oxygen of an air even at a high temperature. So they are the least reactive. Next, the reaction of an aluminum metal with oxygen. Aluminium reacts with an oxygen to form aluminum oxide. So the formula for the aluminium is Al plus O2 gives Al2O3. Next, the reaction of an zinc oxide and aluminum oxide. The aluminum oxide and zinc oxides are insoluble in water. The aluminum oxide and zinc oxide are amphoteric in nature. As amphoteric substance shows both acidic and basic character. It reacts with a base like acid and it reacts with an acid like a base. So when zinc oxide reacts with a sodium hydroxide, it behaves like an acid. That is zinc oxide when reacts with a base. So NaOH is a base, so it will behave like an acid. In this reaction, the sodium zincate and the water are formed. So such metal oxide which reacts with both acid as well as a base to produce a salt and water, they are known as an amphoteric oxide. So what is mean of an amphoteric oxide? So the example for amphoteric oxide is aluminum oxide and zinc oxide. So they will source both the type of properties, that is acids as well as a base. For example, when it will be reacts with a base, it behaves like an acid. When it will be reacts with an acid, it will behaves like an base. For example, if zinc oxide reacts with an sodium hydroxide, sodium hydroxide is an a base. So what happens? It will behaves like an acid. So when amphoteric oxide, that is a metal oxide, when reacts with both acid as well as an a base, they will produce an salt and water. So that type of an oxide we are calling as an amphoteric oxide. So we can see the equation. Zinc oxide when reacts with an base, that is NaOH, it will behave as an acid. So it will form an sodium zincate and water, that is this is an salt. So ZnO plus NaOH, it gives an sodium zincate, that is Na2ZnO2 plus H2O. So here the zinc oxide behaves like an base when it reacts with an acid. So the zinc oxide gives zinc chloride and water on reactions with an hydrochloric acid. So here it will reacts with an acid, so it will behaves like an base. So ZnO plus NHCl, it gives ZnCl2 plus water. So in similar way, the aluminum oxide behaves like an base when it reacts with an acid, and behaves like an acid when it reacts with an base. So we can see the example. Aluminum oxide gives sodium aluminate along with the water when it reacts with an sodium hydroxide. So Al2O3 plus NaOH, it gives sodium aluminate, that is NaAlO2 plus H2O. So here what happens, that is an aluminum will behaves like an acid when it reacts with an base. So here this is NaOH is an base. So when aluminum oxide reacts with an base, it will behaves like an acid. Next, the aluminum oxide gives aluminum chloride along with the water when it reacts with an hydrochloric acid. When it reacts with an acid, what happens? It will behaves like an base. So here Al2O3 when reacts with an hydrochloric acid, it gives aluminum chloride, that is AlCl3 plus 3H2O. So these are the example of an amphoteric oxide. So all the metals do not react with the oxygen at the same rate. Different metals shows a different reactivity towards oxygen. Metals such as sodium, potassium react so vigorously that they catch fire if it kept in the open. So now listen. So this is a sodium. So always will keep a sodium in an immersed in a kerosene or oil. Okay. When it will be left or it will be react with an water, what happens? It will catches on a fire. So this is the burning of an sodium on its reactions with an water. So it is react vigorously with an oxygen. So for to prevent this one, what happens? The sodium will be kept immersed in a kerosene oil. So this is the meaning of this one. That is, metals such as sodium and potassium react so vigorously that they catches fire even it kept in the open. So hence, to protect them and to prevent the accidental fire, they are kept immersed in the kerosene oil. At the ordinary temperature, the surface of the metals such as magnesium, aluminium, zinc, lead, etc. are covered with a thin layer of an oxide. So the protective oxide layer prevent the metal from further oxidization. Oxidization means corrosion. So here, that is in ordinary temperature. What happens? The surface of a metal such as we can say magnesium, aluminium, zinc, they will form means they will be covered with a thin layer of oxide. So to protect from further oxidization. The iron does not burn on heating, but the iron filings burns vigorously when sprinkled in the flame of the burner. So in this one, the iron does not burn on heating. So when you burn an iron, it will not heat. But the iron filings, when it will be sprinkled in the flame, what happens? It will be burned vigorously. The copper does not burn, but the hot metal is coated with a black colored layer of a copper oxide. So you can see in your home that is in a copper vessel will not burn, but you can see in a copper coated with a black color. So that is the formation of an a copper oxide. Silver, gold do not react with the oxygen even at a high temperature. So these are the how the metals reacts with an oxygen and how the reactivity will be this one. So next, anodizing. So here it is, this is a new term. Anodizing is a process of forming a thin oxide layer of aluminium. So we have seen already that is some of metals, just like what at ordinary temperature some surface of metal like magnesium, aluminum, zinc, lead, etc., they will be covered with a thin layer of oxide to prevent further oxidization. So this that is magnesiums, when it will be covered with a thin layer of an oxide, so that process we are calling as an what, anodizing. So anodizing is a process of forming a thin thick oxide layer of aluminium. So here the aluminium develops a thin oxide layer when it exposed to the air. So the aluminum oxide coat makes it resistant to further corrosion. So the resistance can be improved further by making the oxide layer thicker. So in this process, what they will be do, that is an aluminum develops a thin oxide layer. So when it will be exposed to an air, so this aluminum oxide coated make it resistance to the further corrosions. We can prevent the corrosions. So how we can make an oxide layer thicker? How can we can improve the further by making the oxide layer thicker? So during anodizing, a clean aluminum particles is made the anode and is electrolyzed with a dilute sulfuric acid. So we can see this is the diagram. So in this one, we are taking an anode. So the anode is made up of an aluminum, and we are taking an electrolytic solution that is a dilute sulfuric acid. So what happens, that is aluminum reacts with an sulfuric acid. What happens, the oxygen gas will be evolved at an anode. So the oxygen gas, what happens, O2 electrons will be evolved and it will be deposited at an anode and reacts with an oxygen to make an thicker protective oxidized oxide layer. So what happens, so this oxygen gas evolved at an anode, they will be reacts with an aluminum. So you know that is an what, when aluminum reacts with an oxygen, it will form an what, aluminum oxide. So this aluminum oxide will make a thicker protective oxide layer. So this oxide layer can be easily dyed dyed to give the aluminum particles an attractive finish. Okay, so here you can see this is that is diagram. So this is cathode, this is anode, and what happens, they will be connected to the battery. So when it will be switched on, the process will be goes on. So at that time what happens, so from an sulfuric acid the oxygen gas will be evolved, and this oxygen gas will be deposited at an anode. So you know that is an anode will be in anode, it will be an aluminum. So aluminum reacts with an oxygen and it will form an aluminum oxide. So it will form a thick layer, protective layer of an oxide, and this will prevent from an corrosions. When this oxide layer can be easily dyed to give an aluminum particles a attractive finish, that it will give an polished surface. So here you can see, so aluminum is an anode. Okay, so this will be the oxide layer it will form after an anodizing. So when the sulfuric acid, so it will be released an oxygen. So what happens, the oxygen will be deposited in the aluminum anode. So they will form the aluminum and oxide, it will react and they will form an what, aluminum oxide film. So this is aluminum oxide film. So this process we are calling as an what, anodizing. Thank you. Hope you all are understood this one. So we will meet in a next session of this chapter.